So we are going to do compound inequalities. Compound inequalities is just an introduction so that we could do a system of linear inequalities. As I mentioned, we could use a calculator to verify our answer when we have inequalities, because we are going to have infinite solutions. Compound would mean more than one inequality, and we want to combine them together, so we can either use an and or. So suppose we have y greater than 5 and y greater than 7. So here I have combined two inequalities with the graph. Excuse me, not with the graph, with and. Now I just want to show that combination and in the graph. So and means something that is in common or overlapping or intersection. So that's what we need. So the overlapping region. So since we have greater than 5, we would have a dotted line passing through 5. Oh, let me change it because the graph doesn't go that far. Say greater than -2. And greater than +2. Greater than -2 could be better. And greater than +2. Before I do that, let me go ahead and shade the region for greater than -2. Now I have another line, so the inequality greater than 2. So this would mean I am going to shade everything above two. So the overlapping part is the one that got shaded twice. So points here will satisfy the given statement. And we call it a compound inequality because we have more than one inequality. N -2, y greater than 2, those two will form a system of linear inequality, also because we drew two different horizontal lines. But didn't have the mx plus b form, so I just called it a compound inequality. So here, system of linear inequalities would mean I have two inequalities and I want to find their solution. So their overlapping part will be the solution. So let's take the first line, y equals 2x plus 3. We know the y-intercept already, so positive 3. Open dot because we have a greater than and not greater than or equal to. I want one more. Let's say if I pick -1 for x, have 2 times -1 plus 3, 3 minus 2, 1. If I pick +1, 2 times 1 plus 3, I get 5. So open dot here, open dot there, a dotted line through, and I will be done. Now it's time to sketch the region. It is greater than, so everything above. So I'm going to shade everything above. Then move on to the second line. -2x plus 5. We already know the y-intercept is 5, and I'm going to put an open dot because we have greater than. Pick some values so that we can draw a line. Let me pick +1, and that would give me -2 times 1 plus 5, 5 minus 2, 3. So I get there, and -2 times 2, I'm plugging in x is equal to 2 plus 5. So -2 times 2 is -4. 5 minus 4 is 1. So when it is 2, we get 1. We need a dotted line. And everything above the dotted line is our solution. Which would mean all of these. That would be above. Since we have a system, a solution that you get must be common to both. The region that is common is that triangular part right there, because that is the overlapping part. So the solution region right there. So the points in that region are the only points that would satisfy the system of linear inequalities that we have. Now, how do we go about doing this using a calculator? Going to look at the first line, 2x plus 3, and the sign was greater than, so up, move to the right so that we can set it. The next one is negative 2x plus 5. This was also a greater than sign, so move to the far left, enter, enter, greater than sign. Oops, what the hell? What happened? Oh, it's right here. Move to the far right and graph. That's the first inequality. Second inequality, the cross-hatched part region, that triangular region, is our solution. And that's exactly what I had here. That triangular region that we have is our solution region.